Okay, here recording in progress. Share the screen. Okay, so my daily reminders, the way things are. So we're finished with lectures. We just take questions today. So tomorrow is a test, not Friday. Tomorrow, exam 5. As soon as class is over today, you can start turning in the homework. This is what you turn in. At least 70% of the homework is required for me to grade your exam. And Friday will just be an office hour, pretty much. There's no new material. You can join or not. I'll get you the solutions video by tomorrow. I may not grade, sorry, by Friday. I may not grade your exam that fast, but hopefully over the weekend, but you can start studying for the final exam. Okay, so again, my suggestion for studying for the final is 1 exam per day, starting with Friday, test 1. The next week, Monday, Tuesday, Wednesday, Thursday, test 2, 3, 4, and 5. The solutions video are always the day after the test, right? So the first test video solution should be Saturday, 9/4. The second one should be Saturday, 9/25, and so on, all the way through. The last one you'll get on Friday. Okay, and our final exam is on the 17th, Friday the 17th. Same Zoom link, 8:10 to 10:40 a.m. And my office hours during finals week next week, Tuesday, Wednesday, Thursday, 8:10 to 10, 14th, 15th, and 16th, not Monday. I have to give another final on Monday. Same Zoom link all the way throughout. Okay. And let's see, what else? Bring polar graph paper. Yeah. So I may decide to give you a polar graph question. So I think I've said it often enough in case I forget to say it anymore, but have that ready. 3 questions from each chapter. 3 times 5 is 15. So expect a final exam of 15 questions, 3 from the first, 3 from the second, 3 from the third, 3 from the fourth, and 3 from the fifth exams. And then we're just about done. Okay. So does anybody want to ask any general questions right now? If not, we can go to specific questions. And I have no lecture. There's no new material. So we're just going to stay as long as anybody has stuff to ask. All right. So any general questions about the structure of the test, the final schedule, anything like that? Okay. Will the exam contain 10 or 11 questions? Well, that was still possible from previous exams, so most likely still 10. Okay. And some of the sections kind of run together, as you know. So a particular question can be something from all the other sections. So 10 questions is still good enough. And there was one section, I think it was section 7, that was just kind of a review anyway. So there was no really new material there. All right. All right, so probably still 10 questions. All right, so at this stage, I've got nothing. So everything is generated by you. You can either unmute yourself or you can start asking me questions. And if not, we're going to adjourn real early. And then you get ready for the test tomorrow. You can start submitting your homework if you wish also. Okay, so I think I'm caught up with the chat. And any questions about anything, about the test or some particular questions in chapter 11, you may ask if you wish. Okay, so let's see 11.1059. Let me just disappear and show you this right here. Okay, so 11.1059 was asked for. Let me see what that's about. Okay, so square root of 1 plus x to the 4th, error less than 5 times n negative 6. Okay, to come up with the series for that is a little bit clumsy. 0 to 0.4, radical 1 plus x to the fourth dx. Absolute value of the air less than 5 times 10 to the negative 6. I'm checking, make sure I got that. Okay. So first I need to come up with the expression for this. Let me start off with radical 1 plus x equals f of x. I'm intentionally leaving off the x to the fourth. I'll put it in later as a function because I don't want to have to fool with the chain rule too much for that. Okay, so f prime of x is 1/2 1 plus x to negative 1/2. F double prime is negative 1/4 1 plus x to negative 3/2. F triple prime is negative 3/8 1 plus x to negative 5/2. And I'm gonna guess that's good enough. Okay. And then I plug in 0 everywhere. So I'm trying to come up with a Maclaurin series. So f of 0 is 1. F prime of 0 is 1/2. Just coefficients because 1 raised to anything is 1. F double prime of 0 is negative 1/4. F triple prime of 0 is negative 3/8. Okay, so radical 1 plus x is 1 x to the 0 over 0 factorial plus 1/2 x to the 1 over 1 factorial minus 1/4 x squared over 2 factorial minus 3/8 x cubed over 3 factorial. Let's dot, dot, dot. 1 plus 1/2 x minus 1/8 x squared minus, let's see, this is 3 over 48. That's 1/16 x cubed, dot, dot, dot. Okay, so now radical 1 plus x to the fourth. X to the fourth. X to the fourth squared. X to the fourth cubed. One plus 1/2 x to the fourth minus 1/8 x to the eighth minus 1/16 x to the 12th plus dot, dot, dot. Okay, so now I'm ready to integrate. One plus 1/2 x to the fourth minus 1/8 x to the eighth minus 1/16 x to the 12th. X plus 1/2 x to the 5 over 5 minus 1/8 x to the 9th over 9 minus 1/16 x to the 13 over 13 from 0 to 0.4. Okay, so plug in 0, you get 0. Plug in 0.4, 0.4 plus 0.4 to the 5th over 10 minus 0.4 to the 9th over 72 minus 0.4 to the 13th over 16 times 13, whatever that is. Okay. And now it's just calculator. Let's see, we're supposed to go how far? Okay, I do see some more problems later, but anyway. Let me check. Okay, this should be a positive. Double check that's not, yeah, sorry, this should be a positive. It's supposed to be alternating. That's easy. That's a plus, 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 that's a plus. Okay, so I have to find something that's smaller than 5 times 10 to the negative 6. So I will guess this one. 0.4 to the 9th power divided by 72. Is 3.6 times 10 to the negative 6. That is smaller than 5 times 10 to the negative 6. Okay, so it means I only have to add up these two. This is 3.7 times 10 to the negative 6. Okay, so just add these up and then you have the answer. 0.4 plus 0.4 to the 5th divided by 10. 0.401024. Is what I have. Okay, I have some more in the chat. I have to open up the chat. So stop the share temporarily. Check the chat. 11.3, 17, 11.11, 21, 11.3, 17, 11.11, 21. Okay, at any time, if anybody wants to add something else, you can feel free to do so. Go ahead and put it in the chat. Okay, so 11.317. Is summation 1 over n squared plus 4. Okay. Okay, at the time we said not to do this by the integral test, we'll use something else. Okay, and that looks very much in the long run like 1 over n squared. So I will compare to summation 1 over n squared. And get this thing focused. There we go. Okay, so I'm using limit comparison tests. Limit n approach infinity of 1 over n squared plus 4 divided by 1 over n squared. And multiply top and bottom by n squared. So that's gone. N squared over n squared plus 4. A lot of things you can do. Divide top and bottom by n squared or do L'Hopital's rule. Do L'Hopital's rule. This is infinity over infinity. So derivative of the top is 2n. Derivative of the bottom is 2n. So I get 1. Which tells me whatever happens to one happens to the other. Summation 1 over n squared converges. So on the exam, you always want to justify. So the reason it's a p series where p is 2 and that's greater than 1. I'm using the p series rule. So therefore, dot, dot, dot means therefore. The original series is always s for us. Also converges by limit comparison. That's LCT. Limit comparison test. Want to put on your formula sheet, page 722, the P series rule. P series summation 1 over n to the P converges if P is greater than 1, diverges P is less than or equal to 1. Okay, and I was also using a limit comparison test, page 729. Put this on your cheat sheet. Okay. You have a given series and you want to change it to a quote unquote easier series. if the limit as n approaches infinity is any positive number, not zero, not infinity, and the limit exists, then either both series converge or both diverge. Whatever happens to the one happens to the other. Okay, 11.1121. I think we already did that one. Yeah. 11.1121. I'm pretty sure I did that yesterday. At the end of yesterday's video. But just to save time, let me see if I can whip it out quickly. Yeah. Yeah, 11.1121. Yeah, I found it. So n equals 4. But we need to take the fifth derivative overall. Okay, so here's the function. First derivative, second derivative, third derivative, fourth derivative. Okay, there's a lot of product rule. This one first times derivative of the second plus the second times derivative of the first, and keep going all the way through. Here was the fifth derivative. We're centered at 0, so you plug in 0. That's 0. That's 0. Sine of 0 is 0. That's 0. That's 2 times 1 or 2. That's 0. That's 0. That's 0. That's going to be -4 times 1 or -4. So T4 is x to the 0 over 0 factorial, x to the 1 over 1 factorial, x squared over 2 factorial, x cubed over 3 factorial, x to the 4th over 4 factorial. And I put 0, 0, 2, 0, -4, 0, 0, 2, 0, -4. Gone, gone, gone. 2 divided by 2 is 1, x squared. -4 over 4 factorial is 24, -1/6, x to the 4th. Okay, and then the remainder is less than or equal to the fifth derivative exponent factorial. And we said yesterday this is maximized at 6. You can only have something between -1 and 1. Cosine is between -1 and 1. Maximum is 1. Same for sine. Make that a 1. So that causes this thing to be 6. The biggest this can be is if I plug in 1, and 5 factorial is 120. So 1 over 20 or 0.05. Okay. Okay, and I see now coming in 11.3, 9, 13, and 17. 11.3, 9, 13, and 17. Okay, so let's see what that's about. Make that disappear. (11.3) number 9. Summation 1 over n to the radical 2. So that converges. That's a convergent P series. P is radical 2, which is bigger than 1. Okay, so that's all you have to do for that one. And then 13, 1/3 plus 1/7 plus 1 over 11 plus 1 over 15 plus 1 over 19. Okay, 1, 2, 3, 4, 5. First term, second term, third term, fourth term. Let's see. 4 minus 1, 8 minus 1, 12 minus 1. So 1 over 4n minus 1 seems to be the rule. Let's check if I plug in 1, I get 1/3, plug in 2, 1/7, plug in 3, 1/11. Yeah, that's it. Okay, so that looks sort of like harmonic. So compare to summation 1 over n, which I know diverges. Okay, got to continue up. Continue up. So the ratio of this to this, limit n approach infinity, 1 over 4n minus 1 divided by 1 over n. multiplied by n over n. These guys cancel out. Limit n approach infinity. N over 4n minus 1. This is infinity over infinity, so L'Hopital's rule applies. Derivative of the top is 1, derivative of the bottom is 4, limit as n approaches infinity 1/4 is 1/4. That's a positive number. It isn't 0, it isn't infinity, and it exists. So therefore, whatever happens to one happens to the other. What happens to this? It diverges. Get this thing to focus here. There you go. So since this diverges, the original also diverges. So summation 1 over n diverges. The reason is because it's a harmonic series. Okay. And by the way, on the exam or final exam, when you get this series, you need to state it's a harmonic series. Don't say it's a P series. It's a special P. I mean, technically it is a P series, but this is a special name for this one. So I want you to say harmonic series on the exam for that. And so therefore, this original series also diverges by limit comparison test. And then I think the last question was 11.317, and I just did that over here. So that is that. Let me just get this thing focused. Okay, so I believe I'm caught up with the chat. But let me double check. I'm sure 11.3, 9, 13, and 17. Okay. Okay. Okay, about yes, the person that just asked about the cheat sheet, formula sheet, you may, but basically just go through the book and you can put any formula that's there, you may as well go ahead and put it on. It can't be wrong to put that in your cheat sheet. Okay, I believe I've caught up. Again, it's hard to keep up with the chat and do the problems out. Ideally, there's somebody that would help me with that, but there isn't anybody, so too bad for me, right? I just survived. Okay, I think I've caught up. Let me check what else. Still about 10 questions. 10, 11.3, 17. Okay, maybe I'll just say if I didn't get to your question or if you put it in the chat and I missed it, since that's possible, go ahead and ask again, or you can unmute yourself. Otherwise, we're finished, folks. Anybody want to ask any other questions, please? Otherwise, that's it.
I have one question for 11.11. So it's just like a general question. So for the homework, I noticed that like you didn't like graph anything, so that's not required, right? For your version of the test.
Well, for graph, yes, we didn't graph. Some of them required a graphing calculator, and I didn't require a graphing calculator for the course, so anything like that you can skip.
Okay, and another thing, so for like 11.10 and 11.11, the final answer is just like the four like polynomials. Like we don't need to write the summations or anything.
Correct.
Right?
So I want you to just write the 4 terms in the polynomial form. If it's a series, put the ... but you don't have to put the summation notation. Yeah.
Okay.
Yes.
Yeah, and 11.11 is mainly without like the series, right? It's like
correct. So the really only difference between 11.10 and 11.11 is instead of ... you stop and it says, give me a 4th degree polynomial. So if it is a 4th degree polynomial, you don't have to put the ... Although in 11.11, you do have to give an estimate of the error by Taylor's inequality, that formula where you have to go to the n plus first derivative exponent and factorial.
Okay. And another thing for the Maclaurin series, like you can only use it for like certain types, right? And also when a equals 0.
Maclaurin series means a is 0, correct. So Taylor series, you're centered anywhere else. But for Maclaurin series, only centered at 0. And that list that I showed you guys, let me hit that. Go ahead and show that to you. Okay, so this one on page 768, the top 5 that I had there, these are all Maclaurin series. They're all centered at 0. They could have series centered somewhere else. And some of the homework problems in 11.10 and 11.11, you were centered somewhere else. That definitely was the case. All right. Let me see. I think that answered your question, but if not, you can ask again. Let me
Yeah,
check.
I'm good. Thank you.
Okay. How should we identify which formulas to use? What is a strategy we can use? Okay. On section 7, I think they give you, one of the harder things about this entire chapter is there's no set rule where you just look at a problem and say, oh yeah, you always do this, 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 this. You kind of have to identify what type you have. So strategy for testing series on page 744. Okay. So number 1, if you see something like that, that's definitely a P series. Okay. Number 2, they give you a geometric series. And number 3, it looks kind of like a P series or a geometric series. That is sort of like this one, right? You look at this and say, okay, it's like 1 over n squared. They added a 4. You know, when n gets super big, the plus 4 means nothing. So I compare it to summation 1 over n squared. Okay, so that's where it says use one of the comparison tests. Number 3. And then page 745, test for divergence. This thing out of the way. If the limit as n approaches infinity of a sub n is not 0, you can use TFD, test for divergence. And once you see that -1 stuff, right? -1 to the n or n minus 1 or n plus 1, think of alternating series tests. Ratio test is a biggie. Okay, so if you see factorials, it's almost always ratio tests. Okay, and some other powers. If you can easily take the nth root, then root test, although that it wasn't that much. Okay, and lastly, it says if you can integrate it, then do the integral test. There is a reason why the integral test is listed last. It's probably the least favorite because you have to do the most amount of work. You have to actually figure out the integration, and it involves infinity, which means change infinity to b, take the limit as b approaches infinity, and so on. So you probably don't want to do the integral test unless you have to. Okay, but it's there. So there's a good chance I might ask you an integral test, but you're just integrating. I mean, all this course, you've been doing a lot of integration already. So yeah. Okay, and I think I've caught up again. Sorry, I have to keep switching back and forth between sharing the screen and not in order to see the chat. Okay, and once again, I think I'm caught up, but I can't really tell if I've done them all. So let me see. For 11.9, we forced the problems to look like geometric series. Yes, there were many problems where you tried to make it look like a over 1 minus r. Yes, that's a good point. So let me go back and share the screen again. So for a geometric series, the sum is a over 1 minus r. This is the first term. And this is the common ratio. And yes, a lot of the problems try to make it look like this, because once you have that, then this means the first term is a, and after that you keep multiplying by r. So ar squared, ar cubed, and so on. Yes, that was a major theme for that section there. In fact, that's how we got some of our familiar formulas, you might recall, like natural log of 2. There was a formula I gave you guys for pi, for e, right? Don't memorize them, but they're just curiosities, I suppose. Okay, I think I've caught up again. It's hard for me to read it. So again, it's easier for me to say, if you put something in the chat and I didn't get to it, type it again or unmute yourself again, please. Okay. Anything else? Otherwise, we're done, folks. All right, that'll do it, folks. So have a good day. You can start turning in your homework even now and be ready for tomorrow's test. All right, bye, everybody. Have a good day. See you next time. Bye.